see it.
What's that, brother?
I'm surprised Sarah's not answering. Mm-hmm.
That is just wild, isn't it? It's kind of like the light's getting gray.
Uh-huh. Oh, how about you hear the crickets already?
Yeah. They think it's night.
And the birds are chirping even. It's like it's almost like, what, a little bit past 5 for them? With how this is? No? No? Okay. That's hot.
I'm getting sick out of here.
Yeah, you should go inside.
Yeah.
Here.
You
I'll sit
watch
out
it.
here. Yeah. Just be
And that's
careful.
exactly what happened. The camera overheated as soon as I took it inside and cooled it off for a few minutes.
I know.
The boiling now.
Yeah, because it was out here for a while. You good?
Oh,
I'll check it.
did I just knock it off?
No.
Huh? Keep it in the frame. Thank you.
Mm-hmm.
So, as the moon has now moved, the sun is appearing again, and we can see the diamond ring. It's amazing. It's fantastic. You see the outer edge. I see prominences, little red pieces of chromosphere from the lower atmosphere. This is amazing. This is absolutely amazing.
Johnny, what we got? That looks pretty cool.
I mean, it's breathtaking. I just, even seeing it right now through the TV, it's just an amazing thing to see. I cannot imagine what we're going to feel here in South Carolina when we have our chance.
Well, I hope we have our chance. Sean, get that weather up here looking good here in Charleston. Now, what do we...
So, Alex,
what are we seeing here?
Is that from the G3? That looks like from the G3 because I see spectra there.
No, it's still from Salem.
That's still from Salem.
Yeah.
Okay, so you're seeing the bright... Actually, the camera is causing a little prism effect there, and you're seeing the bright light from the edge of the sun. So that is really beautiful. That's sort of the edge of the diamond ring effect.
Yeah.
So, Alex, a reminder, Alex, so when that diamond ring pops up, that's when people should put the...
That's when people should put your glasses back on. So when you see that diamond ring after totality, that's the signal to you that it's time to put it back on.
Yeah.
So look now, we see the corona in Madras. That's gorgeous.
That's amazing. Being able to look at that with your own eyes is an amazing experience. And that only can be seen when you have this kind of totality.
So the corona, that's the
solar atmosphere.
That's what solar scientists really live for, right?
Right. Right. That is the where the origin of space weather.
Yeah.
That's where it comes from.
That's where most of the solar flares, the corona mass ejections, big explosions of particles originate from.
Now, if there was solar activity, would we see it right now? Would we be able to see that popping up on the side?
The coronal mass ejection leaving the sun, we could see it there because, in fact, we have seen it in the past, and I'll even show some history later, which is that people drew of these coronal mass ejections leaving the sun during a total solar eclipse.
Now, why is it so critical and so important to really get this type of view from the sun's atmosphere from the corona? Johnny?
You mean like in a total solar eclipse?
Yes. There's the diamond.
That's
there
the diamond ring again.
Ring.
That's amazing. That's from Madras.
Yeah.
It is important to do this because
cool.
we do this kind of eclipses artificially, but we do not do it as perfect as nature does. The moon covers the sun in such a perfect way that we see parts of the corona that we don't usually see.
I know. I'm happy out
So
here.
Alex, explain that and safety too, right?
So right now, this was the moment when you see that flash of light. That's the moment when it's time to put your glasses back on or start using your indirect methods because now it's too bright and it can damage your eyes.
Yeah. Safety first, people. Always.
Wow. So the folks in Salem, Oregon, I mean, they're like, juiced. They got it. They got the good.
They've got a perfect view, and they are seeing one of nature's most amazing spectacles.
I can only imagine the reaction on the ground from the folks there.
Oh, they are probably
Gasping.
completely overwhelmed right now. Completely overwhelmed.
Well, I certainly hope we get something like that. But we've got it here on NASA television through the eyes of NASA. And we got the International Space Station coming up and other images only we can bring.
Only NASA can bring, yes.
Now, is it completely dark or is it coming out?
No, what's happening now is the filters are back on, the safe solar filters for the telescope, and now you see the crescent, which is the sun, basically now being revealed after the eclipse. So we're now back to the partial phase in the other direction.
Exactly.
Now, how fast is this going?
Well, this shadow is passing across the country, depending on where you are, anywhere from 1,200 to 1,800 miles an hour. So this is moving incredibly fast because the moon itself, in its orbit, is moving at almost 3,400 miles an hour. And that, in combination with the rotation of the Earth, is what gives us a shadow moving that fast.
Okay, so, Gotti, let's talk about space weather. Seeing this and space weather is so important. So just let us really understand why it's important on space weather.
right. We apologize. There is no audio on that video, but it talks about the solar system ambassadors. There are about 720 in the United States. They get special training from NASA. They learn all about the missions and about the science, and they basically go out to public events all over the country teaching them about NASA missions. If you would be interested in becoming a solar system ambassador yourself, you can. We have a website. Look it up, Solar System Ambassadors. It is a NASA website, and starting September 1 through the end of the month, you can sign up to be a solar system ambassador. So check it out on the web, Solar System Ambassador. With me now is Jim Green. Jim Green is the head of planetary science for NASA. He's in charge of all planetary missions and asteroids. This guy knows his stuff. Let's talk about this. Now, you see this eclipse that doesn't happen. It happens once in a lifetime.
Wow.
But as a scientist, you see it as an opportunity.
Oh, absolutely. I mean, we're getting the eerie feeling right now, but when we launch balloons, and there'll be 57 balloons along the path, 30 of which are going to have a planetary experiment on them.
And we have video of this. Now, just a few days ago, we had a crew here. They did a test launch for us, and they sent up an imaginary payload for us just to see how it all works. You have actual scientific experiments going up.
We do. We have a bacillus. It's a harmless bacteria. We have on 30 balloons 2 coupons where the bacteria will be sprayed. One will stay on the ground. One will be affixed to the balloon. It then will go up to 100,000 feet above the ozone. So
Go
the
inside.
ultraviolet light, also blocked a little bit by the moon, is just like Mars. In addition to that, the temperature and pressure will be just like Mars. So when the balloon goes up higher and bursts, comes down, we'll retrieve that coupon off the balloon, match it with the one on the ground, and then we'll see how many survive.
Now, why is that information so critical for Mars research?
Well, this bacteria is pretty much everywhere. It's very hardy, and it probably has made its way to Mars, perhaps even on our rovers.
Did
And
you
I
see?
would like to know if that environment is
See
so
right there?
harsh that it would eliminate
it?
that bacteria
That's the
or
sun.
not.
All right.
It's being
I'm
covered up by the
selfish.
moon.
I have never seen a total eclipse. And I'm sorry, I would love to talk to
Hey,
all
go
of
inside.
you people, but
Don't
I
look
want
up.
to put on my glasses too and take a
Good
look.
job.
Can we continue this conversation?
I love you.
All right, and watch, and we can talk.
Tell Daddy I need water.
So
What
we
a little
still,
sliver.
just a little sliver of the
Yeah,
sun
go
right
tell
now.
Daddy.
And let's talk about this. Why is this so rare?
Well, you know, the plane of the moon relative to the Earth's sun line is tilted by 5 degrees. And so there's only 2 places where the moon and the Earth and sun are on that same line. And that's why every 18 months or so we get an eclipse.
Hi.
Look how dark it is.
Stay.
Clover, listen.
Oh, wow.
Uh-huh. Oh, shit.
Close the door now.
Here, hold this for a second, Chase.